times 3, which is 15. So these are both just 5 times as big as what they were. Just multiply both by 5. Questions on that? Tomorrow? So this is a constant, that's where we got the 5. And the 15 came because that's the mean of x. Really? No. For the following, these are the transformations. So each transformation we have to do. Good question. I feel like maybe others in the class had it, but they didn't want to ask. All right. So the next one says 5x plus 8. So that means I'm multiplying by 5, then adding by 8. So if you look at the formula sheet, this is formula row 2. Row 2 says I have a times x plus c. A times x plus c. So it says that in order to find the new expected value, we're going to say, what is a? Well, in this case, a is 5. What is the mean or the expected value of x? That's 15. Plus 8. So we have 75 plus 8, which is 83. Sure.
So basically, whatever x is, we're putting in the mean is.
Right. Whatever the mean is, whatever the standard deviation is, you plug it in. Yep. So now, when it wants the standard deviation, if you notice, the formula is, it doesn't matter if you add a constant. We talked about this in Unit 2. Adding a constant does not affect the standard deviation because every number goes up by the same amount. So that does not affect the distance each number is from the median or from the mean. So the formula for a standard deviation says, well, the standard deviation of a, some constant, times x plus c is equal to a times the standard deviation of x. That's the formula on row 2. So what is a? Well, a in this case is 5. And what's the standard deviation of x? 3. So the answer is 15. Are we recording, by the way? Yeah. Thank God. So let me stop question A and B, Shamar.
Can you re-explain why you don't add 8?
Yeah. So if every number goes up by the same amount, so like I add 3 to every number, then the average also goes up by the same amount. But the standard deviation, which remember is the distance from the average, is not going to change because every number is just shifted over by 3. So it's not that the distance away from the average has even changed. It's just shifted.
So the constant you add or subtract by does not
Affect standard deviation. But it does affect mean. It does affect mean. Tomorrow.
You have s parentheses every time x plus c, right?
Right.
Why don't you plug anything in over there?
No, because if you notice on your formula sheet, that simplifies to a times sx. You see that right here? Simplifies. Row 2, column 2. So it just simplifies to this. So let me just plug in here where it's easier. Does that make sense? Does it make sense plugging in? Okay. Great. All right, now here's where things get slightly a little bit more complex. Slightly more complex. So, but again, it's all using the formulas. Like that's the key. It's all the formulas. So here we want to say 1c. We want to find the mean, or x bar, of x minus y. X and y are just random variables. So let's take a look. Our formula sheet says on the bottom row, we do the expected value of x minus the expected value of y. So this is equal to expected value of x minus expected value of y. The expected value of x, expected value is another word for average, another word for mean, is 15 minus 18, negative 3. Now we want to find the standard deviation of x minus y, which is equal to, please note what the formula says. The formula says the square root of the standard deviation of x squared plus the standard deviation of y squared. This is not a typo as we write. We always add these. Always. Always, always, always. Regardless of what's happening here, this is always a plus sign. Always, always, always. So, now this is pretty doable. Standard deviation of x is 3. So let's square it. 3 squared. Plus, standard deviation of y is 4. 4 squared is the square root of 9 plus 16, which is the square root of 25, which is equal to 5. Questions?
You said that was the most complex? Or that
No,
was a little bit
these four. These two are more complicated than these two, I think. Because you have x and y. All right, and now let's see 1D. We'll do it over here. Will this pick up on the recorder, Brian? Over here?
Yes.
Okay, so 1D says 3x plus 2y. So this is on the back of the formula sheet. Row 1 on the back of the formula sheet says expected value of a times x plus b times y equals a times the expected value of x plus b times the expected value of y. It's just the formula, and now we just literally are plugging into the formula. So, a, 3, expected value of x, 15, b is 2, expected value of y is 18, and then we get our answer. 3 times 15, 45. 2 times 18, 36. The sum is 81. Again, you need to stop me if there's questions. I think it's like literally, here are the formulas, like plug it in. Brian.
Can you give another example for the first two for A and B? Because I feel like those are the two that I got most.
Yeah. So we will have those here, and you should try them, and I'll definitely. All right, and the last one is standard deviation, and this is just to the right. It says standard deviation of a times x plus b times y equals what? Well, it's the square root of a squared. So you square this first number times standard deviation of x squared plus b squared times the standard deviation of y squared. Next.
Expected to move up this.
Yeah, not by tomorrow, not by the day after, but by. I mean, you memorize the alphabet.
No.
It seemed hard at the beginning.
No, I did not.
All right, so here we go. So, a squared, a is 3.
9.
A is 3. We have 3 right here, so that's going to be 3 squared times standard deviation of x. Well, the standard deviation of x also just happens to be 3. So I'm going to put times 3 squared plus b squared. Well, b is 2. So I'm going to put 2 squared times standard deviation of y squared. Standard deviation of y is 4. So I'm going to put 4 squared. And then this is right on the calculator. So let's see what we get. This is 9 times 9 plus 4 times 16. But I think like most people should just like plug this in. Like you don't need to simplify it by hand. But basically, this will be square root of 81 plus 64, which will give you some number. So any questions on how we did any of these? Literally, it is take the formula, like plug in. So let's try these on our own. I have the answers, and I'm totally happy to answer questions. Like try it on your own. See how we do. Use the formula sheet. It's given for a reason. We should get this done in like 10-ish minutes, and I want to come back together. Frida. Okay. A is the number multiplied by x. So 3. And 4 times. Okay, so let's go ahead and try these.
That's years. Not year, years.
Oh, let's try it, Dex. And again, right, the like more efficiently we work now, the like less of these problems will be due for homework on Thursday, right? So like, let's work efficiently, ask questions. Any questions here? We are not going to turn in the CFU, by the way. That's fine. We're not going to turn that in. We just turn in the practice problems.
You're not turning this in.
Yes.
Oh, I know. I can just send
Well, let's use the time effectively. So let's ask questions. Let's get this
You
down.
would use this one.
Correct. Yep.
It's the variable. And
3 times x. So what is x here?
So then x would be the mean.
30. Yep.
So it's 10.
Wait, so that's right?
30 is the mean. Yep.
Then you would use a, which is.
What about standard deviation?
3.
You also want to do for both mean and standard deviation on both.
What do you mean for A?
Yeah. For all of them, you find both the mean and the standard deviation. Doesn't it say mean and standard deviation? Does that make sense? So is this a stopped, Brian?
Question.
Yeah.
Okay, so since 6 doesn't have a variable.